This meeting is being recorded.
In problem 15, we're asked to show the Grignard reaction that could be used to make each of these compounds. And we'll have to provide our starting material, the aldehyde or ketone. So let's take a look at example A here. And we would begin by identifying our alpha position. So that would be here. So we want to consider any possible carbon-carbon single bond disconnections that could be made adjacent to this alpha position to generate a suitable electrophile. So if you recall, an electrophile like a carbonyl is what's going to be utilized when we have an aldehyde or ketone. So this is our electrophilic site. And our Grignard reagent is our nucleophile. And if you recall, the general form of that would be something like this, an alkyl magnesium bromide. So this is our nucleophile here. And so what happens here, if we were to disconnect our bond here, we could see that this would be a methyl portion, and we could create our nucleophile here as a methyl magnesium bromide. And this will have that partial negative charge associated with it. And then our electrophile will be generated from the remainder of this compound here. So if we were to draw this, we could have something like this, our aldehyde starting material, and this is our electrophilic center. So we could have this option. So this is one way of creating our compound, or we can also have a different Grignard reagent on the other side. So we could disconnect this bond on this side, and then we would need to add an ethyl group, right, to our to serve as our nucleophile. So we could have something like this, right, as our Grignard reagent here, our bromo-magnesium alkyl group, and this would generate that that negative charge there on that carbon. So that would be our nucleophile, and then our electrophile would be something that looks like this. And this would be our partial positive center. So either of these sets of reagents would be useful and would generate that Grignard reagent. So let's look at reaction 2 here, and we'll do the same thing. So we'll identify our alpha position, and we'll see any disconnections that could be made. So we could do break a bond here, or we could break a bond here. So in the first scenario, our electrophile would look something like this. And so let's make a column, our electrophile, and then our nucleophile would be, we have to add one one carbon additional. So we could have a methyl magnesium bromide as our nucleophile. So that was for this disconnection on the right. If we look at this disconnection here, then our nucleophile would be something like this here. And this would generate that delta negative, that nucleophilic carbon, and then our electrophile would be what's left, right? So we would have this carbonyl compound here, this ketone. So depending on where we break our bond, we can see multiple reagents that would generate the same compound. So let's do that again with compound C here. So this is my alpha position. So I know that I just have another hydrogen here. So if I were to try to break the bond in any location to generate an electrophile and a nucleophile, I could see one site that I could form this disconnection. And if we do that, we can see this side over here could be my nucleophile. And then the rest of the compound, my electrophile, would have to be an aldehyde, specifically formaldehyde, to generate this specific compound. So this is my nucleophile, my Grignard reagent here, and then this is my electrophile, my aldehyde.